All right, so I'm going to do version A, and I will give you the answer for version B. We'll be looking at both of them in class tomorrow, but I want to get this up and done tonight. So first thing I know is that I'm going to do all of them. You only had to do 4, but I'm going to do all of them because some of you need some help on all of them. First one says you have a person standing in an elevator. So the first thing I want to do is I want to draw a free body diagram. Please notice that free body diagrams have arrows to show you the direction of the force. So this is the weight, which is mg. This is the tension. I'm going to let anything pointing up be positive and down be negative. So for part A, if I know that net F is equal to ma, then I have T positive, W negative. My acceleration in part A is upward, so that helps me to know that it's a positive 3 meters per second squared. And yes, it matters what the sign is. So if I'm looking for the tension, and actually I think we're looking for the reading on the scale, so I really should call that the force normal because that's the push of the scale on the rider's feet. That's the force normal. So we're going to go over here and call this force normal rather than tension. It would work the same because you could talk about the tension in the elevator cables, but we need to go with force normal. So force normal is ma plus the weight. Well, the weight is mg, mass was 45. Gravity is always 9.8 if we're on planet Earth. So the elevator is going to move a person that weighs 441 newtons. So that's going to be 45 kilograms times 3 meters per second squared plus the weight of 441 newtons. That's going to give me 136. I'm going to add that to 441. And if I did that correctly, I should get 576 for this answer right here. And that makes sense because if you're trying to pull the elevator up, you're pulling against gravity and you're accelerating. So that makes sense. Should be less for answer B because he's going to accelerate downwards. Same equation, force normal minus W equals ma, but this time the acceleration is downward, so downward we picked as negative, so I'm going to have force normal negative ma positive W. So my mass is 45 kilograms. My acceleration is -2 because it's downward. And I'm going to add 441 to that. So I have -90 plus 441. So my force normal is going to be equal to 351 newtons. Now, C says it's not going to accelerate at all because it's moving at a constant speed. So if net F is equal to ma, and I'm doing part C right here, then I have the force normal minus the weight is equal to ma. This whole side is 0 because it's not accelerating, so the force normal is simply the weight of the man. And he weighs 441 newtons. How do I know? We calculated it right there. If you had the other version of the test, let me give you those correct answers so you can check your work as you go. This would have been 590. A would have been 590, so I'll write it up here. B should have been less than that because you're accelerating downward, so gravity's helping you. And C is just the weight of the man, which is 490 newtons. So that's for version B, number 1. So if you need to pause and study this, go ahead and pause because I'm fixing to move on to the next question and this will all disappear. All right. Okay. Question 2. The biggest problem for a lot of people was that they could not figure out how in the world to use these distances. So here's your x-axis. So mass A is located at 1 meter. So from the origin out, mass A is 3.2 kilograms, and that distance from here to here is 1 meter. B is located at 2.5, and it has a mass of 4.6 kilograms. So from here to here is 1.5 meters, because the whole distance is 2.5, so that means from the origin to there is 2.5. And then C is 2.6 kilograms, and it is another meter away. Because this one is at 3.5, if that's at 2.5, you have 1 meter. Okay, part A wants to know the net force on mass A. Well, every object in the universe attracts every other object in the universe. So B is trying to pull A toward it. C is also trying to pull A toward it. So the force of B on A, added to the force of C on A, will give me the net force on A. I added them because both of them were pulling A to the right. So this is going to be big G, mass of B, mass of A over R squared, plus big G, mass of C, mass of A over R squared, is equal to the net force. The R is the distance between the two objects. So big G, this was 4.6 kilograms. This was A, 3.2 kilograms. And they're separated by 1 meter. And then I did the same thing here. C was my 2.6 kilograms. Still looking at A. A is still 3.2 kilograms. And the distance from A to C, if you added those two up, you would get 2.5 meters. Don't forget to square it. So for version A, which is what I'm working first, I got a value of 4.36 times 10 to the minus 10 for one of them. So let me make sure I'm telling you which one it's for. Alright, and I've already made a mistake. This should have been my 1.5. 1.5, my bad. Okay, so if I'm looking for the force between A and B, it was 4.36 times 10 to the minus 10th newtons. And to that, I wanted to add the force of C on A. What is C doing to A? Well, it's pulling it with 3.88 times 10 to the minus 11th newtons. And so when I added those up, I wound up getting 5.25 times 10 to the minus 10. Let's have a math error, and I hope I don't think I do. All right. Then part B. I needed the force of A on B and the force of C on B. Now pay attention to your directions. A is trying to pull B in that direction, so I'm going to make that be negative. C is trying to pull B in that direction, so I'm going to make it positive. So it was big G, mass A, mass B over R squared, plus big G, mass of C, mass of B over R squared. Alright, so we already know the force between A and B because we calculated it when we first did the first problem. So that's my 4.36. It's negative because it's to the left. 36 times 10 to the minus 10 newtons. And then the force between B and C, when I calculated that, I got 7.98 times 10 to the minus 10 newtons. And so when I added this one to this one, I got a positive value, and it was 3.62 times 10 to the minus 10. Okay. Last one to need to do is letter C. So C, I need to find the force of A on C plus the force of B on C, because A is trying to pull C to the left, B is trying to pull C to the left. So we've already done the force between A and C. We did it right here. So 3.88 times 10 to the minus 11th newtons. And then we found the force of B on C was 7.98 times 10 to the minus 10 newtons. So if I want to, I will add those because they're in the same direction. Both of them are to the left. And when I did that, I got 8.87 times 10 to the minus 10th. And it's to the left. You don't have to tell me that, but it is to the left. All right, so I'm going to tell you to pause it because I'm fixing to look at the answers for B. And when I hit this, it's all going to erase, and then I'll come back and put in the answers for B. All right, so if you had version B, this one I got to be 5.6 times 10 to the minus 10, and it works identical to version A, just different numbers. If you had letter B, test B, number B, you had, or part B of number 2 is 3.64 times 10 to the minus 10. And then finally C was 9.23 times 10 to the minus 10. Don't forget for this one that you really are subtracting them because A is pulling B that way and C is pulling B that way. So A on B, and then this one is C on B. So one's positive and one's negative because one's to the right and one's to the left. So I'm going to get rid of that and move on to number 3. Actually, I'm going to save this one, and then we're going to do 3 and 4.